Good day, everyone. So for today, we will have the eighth topic of your physical chemistry, properties of non-ideal solutions. So kasama rin sa topic na i-discuss ko for this coverage is the colligative properties. Okay? So let's start. Medyo mabilis lang itong topic na to. Okay? And the colligative properties. These are properties that are dependent on the amount of solute and the nature of the solvent, but take note, it does not depend on the nature of the solute. Okay? So ideal solutions, if you remember, one of the criteria is that the ideal solutions must not have heightened interaction. Okay? So dapat walang heightened interaction para masabing ideal. I hope you still remember this. Okay, so one of the heightened interaction that can be that is evident sa mga chemicals na or sa mga species natin ay yung ion dipole interaction or ion dipole interaction, or in short, sa colligative properties, ideal solutions, the solute do not form ions. Okay, so hindi nagpo-form dapat ng ions para hindi magkaroon ng heightened interaction. And so actually, this is the proper term, heightened. So in order for us not to have a heightened interaction, okay, dapat mahina yung interaction between the solute and the solvent particles, which is, an example nga, is ion dipole interaction. Okay? Kasi pag nagkaroon nun, hindi na yun ideal. That is for non-ideal solutions na solutes form ions. Okay? So next. Now, the colligative properties for ideal solutions, okay, if you remember, from your general chemistry, there are four colligative properties. So first is vapor pressure lowering. We have tackled this already. Napadaan na natin to sa LV equilibrium. Okay, that the solute particles hinder the vaporization of the pure solvent. Okay, so ito yung diagram, same. Bumababa yung vapor pressure because of the interaction of the red ones, yung solute, with the solvent. Okay, yung color blue natin in this diagram. All right, now let us proceed. So the colligative property is the lowering itself, the change itself. Yung delta P, yung colligative. Okay? So as you can see, delta P is just simply pressure P naught A. Anong ibig sabihin nito? When you say P naught A, it means the vapor pressure of pure solvent A minus PA, which is again the vapor pressure of the solution. Okay? And if you get the difference, delta P is your vapor pressure lowering. This is your colligative property. Okay? And upon some derivation, actually nakuha ito sa Raoult's law. The final form of the equation was obtained from the Raoult's law. So anong sinasabi? Remember the Raoult's law? It says that PA is equal to XA PA naught. So if we substitute this term here for this, okay, what will happen? Your delta P will become PA naught minus XA PA naught. And if we factor out the PA naught, okay, PA naught, you will have 1 minus XA, and of course, 1 minus XA will be XB if you have two components. So therefore, one of the final formulas sa colligative is that the delta P is equal to XB PA naught. Okay, so dun siya galing. Okay? All right. So pinakita ko lang yung derivation, but then again, if you are not the type who's into the derivation of equations, of course, you must compensate by memorization. Okay, so delta P equals XB PA naught. Next, osmotic pressure. So this is simply the pressure needed to prevent osmosis. Okay, pressure needed to prevent osmosis. When you say osmosis, it is the transport of solvent particles to a more concentrated solution through a semi-permeable membrane. When you say semi-permeable membrane, it means that it allows, in this case, it allows the solvent particles to go through while blocking the solute particles. Okay, so ang travel nito is from a more concentrated solution, from less concentrated solution, less concentrated with solute, to a more concentrated solution with solute. Okay? You would, siguro some of you will say, sir, hindi po ba baliktad? Hindi, kasi ang nag-transport ay yung solvent. So, osmosis, papunta siya dun sa, the solvent particles ay papunta dun sa more concentrated para ma-even out. And the pressure, to prevent that, is the osmotic pressure. Okay, and that is simply, napakadali ng formula, pi is equal to CRT. So wherein the C is the concentration, R, universal gas constant, and T is temperature. Pi equals CRT. Very easy. Okay? Common sa board exam, pwedeng lumabas sa PChem, pwede rin lumabas sa INORG. Okay? BPE, boiling point elevation. So boiling point elevation, same reason, because of the interaction of the solute and the solvent particles, okay, tataas ang temperature needed to boil. Okay? So, since this is an elevation, the delta TB is equal to TB minus TB naught. TB has a higher value. Okay? Kasi TB pertains to the boiling point of the solution, which is of course will be higher kasi nga boiling point elevation, minus the boiling point of the pure solvent. So, TB minus TB naught. Okay? And that is equal to KBM for ideal solutions. KB is called the ebullioscopic constant, and your KB is dependent on the nature of the solvent. Kung ano man yung solvent niya. Okay? And the KB for the universal solvent is, you must know, dapat alam nyo. Okay? And the KB is equal to 0.512. Some references, 0.52, it's fine. Okay? So 0.512 degrees Celsius per molal. Okay, for water. And M here is the molality. So you need your prior knowledge sa conversions just in case hindi ibigay sa inyo yung actual molality. Okay, so delta TB equals KBM. Now, let's go to the freezing point depression. It is the opposite. Mas mababa naman yung value ng freezing point ng solution compared to the pure solvent. Okay, so think of it as mas madaling mag-achieve ng solid structure. It is easier to achieve solid or crystal structure if your substance is pure. Okay? Kasi pare-parehas. If your substance is impure, you will need a lower temperature, okay, to achieve the same crystalline structure or to achieve the solid state. Okay? So same reason. So since this is depression, okay, delta TF is equal to TF naught minus TF. Take note that the deltas here, yung mga colligative properties natin na delta, should always be positive. Kaya ito, opposite to nung kanina, na TB minus TB naught. Kasi at this time, since this freezing point depression, bababa yung TF. So, TF naught minus TF. Okay? Binaliktad natin yung may naught at saka yung wala. Simply because your delta or your colligative properties must be positive. Okay? So, lagi yan ha. The delta TF, delta TB are always positive. And kagaya ng formula, no, delta TF is equal to KFM. KF naman is called the cryoscopic constant. Okay? And the value for water is 1.86 degrees Celsius per molal. Yun yung dapat kabisado nyo. If you have other solvents, dapat ibigay na. Okay? Sana ibigay na yung KB at saka KF. Okay? So, yun. Yung mga formulas natin for ideal solutions. And let's have an example. Okay? Very common na example sa inyong mga universities. Okay? So, you know the drill. Pakisagutan on your own. Then, we will reveal the answer. Or we will solve together first. Okay? So, let's answer. You asked to determine the molar mass of the compound. Okay? And you're given the freezing point of the solution is 1 degree below that of pure benzene. Although you do not, kahit di nyo alam, even if you don't know the TF naught of benzene, it's fine. Kasi you're directly given the depression, yung mismong pag-decrease. Okay? So 1 degree below that of pure benzene. So therefore, your delta TF is already given. It is 1.0. Okay? Then you are given the mass that is 75 grams, and you are given, This is the mass of the solute. So the mass of the solute, 75 grams. Okay, and the mass of the solvent, solute and solvent. So the mass of the solvent is 750 grams. The Kf is given. Baka mamaya gamitin nyo 1.86. Hindi nyo ma-realize that 1.86 is applicable only to water. Okay, so 5.12 degrees Celsius per molal. Okay, so what will we do here? Pwedeng i-derive nyo yung form, pwede ring i-shift solve nyo. Okay, so remember, the equation is delta TF equals KFM. Okay, and your M here is not mass ha. Take note of that. Although they have the same notation, the M here in the equation is molality. So we have to convert pa yung molality. So remember, molality is moles over kilogram of solvent. Okay, specific yun ha. Kilogram of solvent. Mole per kilogram. Okay? And pinapahanap sa atin is the mass of the, molar mass of the solute. Okay? Again, this is mole solute per kilogram of solvent. So in order to get the molar mass of the compound dissolved, which is yung solute niya, okay, we can convert this into mass of the solute over the molar mass of the solute. Okay? So kung ayusin natin yung equation, your delta TF will be equal to KF M molar mass ng solute over, mass of the solute over kilogram of solvent, okay, times the molar mass of the solute. Alright? And pwede kayong mag-derive, pwede kayong mag-shift solve directly. It's in your preference. Okay, so i-rearrange ko lang. So the molar mass of the solute will be equal to KF M sol delta TF then kg, kilograms of solvent. Okay, so our KF is given as 5.12 degrees Celsius per molal. Okay, and your M sol, okay, the mass of the solute is 75 grams over delta TF is 1 degree Celsius. Okay, and the kilogram of solvent is 0.75. Okay, kilograms kasi ha, 750 grams yung solvent. So in kilograms, this is 0.750 kg. Okay, so we can now compute. So the value will be equal to the value will be equal to 512 grams per mole. Okay, so yeah, yun yung answer. Answer 512. Okay, so I want you to try the second question. So pa-assignment nyo to. Please answer this on your own. Then again, the drill, you can consult with me kung tama yung solution nyo. But in this case, I will reveal the answer so that you can self-confirm first. Kung hindi talaga makuha, I'm just one message away. Sana all. Joke lang. Okay, so yeah. Here are the answers. Kung mapalabas nito, it's good. Okay, kung hindi man, edi can consult with me. Okay, next. So, tapos na tayo sa colligative ng ideal solutions. Let's now go to the non-ideal solutions. So, these solutions, they form ions. Okay, one of the clues is that they form ions because of the heightened interaction of the solute and solvent particles. Okay, so the vapor pressure lowering, okay, yung XB natin kanina, mole fraction, will now be replaced with AB. Okay, which means activity. Mamamaya makikita natin yung activity in our next topics. Activity is like the real concentration, parang ganon. Yun yung real concentration. Okay, yung XB, yun yung ideal, parang ganon. Okay, parang sa ideal gas. Okay, so next, for osmotic pressure naman, meron tayong i-introduce na panibago, that is panibagong parameter, which is I. Mamaya ko sabihin kung ano yung I. So, dadagdagan nyo lang ng factor na I. And for the boiling point and freezing point depression, they have I din. Parehas na I. Na-timesan nyo ng I. So, ano ba yung I? So, I is called the von Hoff factor. So, von Hoff factor I can be obtained from this equation. For dissociation of ions, for ionic compounds that dissociate, for example, your alpha is equal to I minus 1 over nu minus 1. Where our alpha is the fraction dissociated. Minsan kasi, remember, yung dissociation, for example, weak acids, weak bases, ganyan, they form, they do not dissociate completely. So, alpha is the fraction dissociated. Okay? So, fraction to, fractional. Ano naman yung nu? It's the number of ions formed. Okay? May it be strong or weak electrolyte. Okay? The number of ions present is the number of ions in the reaction. Okay? So, let's have an example para mas maintindihan natin yung paggamit ng I. Okay? So, a brine solution containing this amount of NaCl was dissolved. What is its boiling point? Ayan. So, first thing that you need to consider in calculating colligative properties is, first, is it ideal? Is the solution, will the solution be an ideal or a non-ideal solution? So, alin ba? Okay, so how will you know? One clue is that you should find the identity, or you should deduce from the identity of the solute. Kung mag-form siya ng ion, di non-ideal. Kung hindi, di ideal. Okay? So, NaCl was dissolved. So, yeah, explicitly stated that NaCl is an electrolyte. So, therefore, we will have the formula for the non-ideal solution ng boiling point elevation. Okay, so let's compute. So, what's the boiling point? You're asked to determine remember this is our equation. You're asked to determine this, TB minus TB naught. This is for pure water, equals I. Don't forget to put I because of the non-ideal solution that will be formed when NaCl is dissolved. So, I KBM. Okay? So, therefore, upon rearranging this equation, your TB will just become I KBM TB naught plus TB naught. Okay? So, TB will be equal to, now that we have the equation, let's now proceed in getting I. So, I, remember the equation, alpha equals I minus 1 over nu minus 1. Our salt is NaCl, and of course, if you dissolve it sa water, full-headed arrow, meaning 100% ang dissociation. It is because sodium salts are soluble. Remember, the solubility rules, they are completely soluble, yung sodium salts, group 1 salts. So, this will be Na plus plus Cl minus. Okay? So, ano ang nu natin dito? Number of ions. So, isa, dalawa. Okay? So, nu is equal to 2. Okay? And alpha is equal to 1 because of the full dissociation. So, upon substituting, 1 is equal to I minus 1 over 2 minus 1. 2 minus 1. From here, your I will be equal to 2. Okay? Then, let's solve for TB. So, TB is equal to I KBM. So, our I is 2. KB for water, hindi nakabigay. Kasi water naman, you should know it's KB and KF. So, it is 0.512 degrees Celsius per molal. Okay, degrees Celsius per molal. Then, molality. Degrees Celsius per molal. Then, the molality is not directly given, but we can find its value. So, molality, again, is mole solute per kilogram of solvent, and you're given this. So, the moles of solute can be obtained from the mass. So, 1.27 grams of NaCl, okay? You have here 58.44 grams of NaCl for every 1 mole NaCl. So, yeah, meron ka na sa taas na moles ng solute, sa ilalim, kilograms of solvent. But you are not given the mass of the solvent, you're given the volume. Pero you should know that in order to convert this ml, this value of volume into its mass equivalent, kailangan nyo ng density, gram per ml. And luckily, okay, we are blessed enough na yung value ng density, okay, ng water at normal conditions ay malapit sa 1. Okay? Malapit sa 1. So, we can assume na 1 na lang yung density. Okay? So, sa ilalim, you have 50 ml of water. Okay? So, gawin natin na grams. So, 1 ml, 1 gram. Saan to galing? Density. Density ng water. Okay? Sir, hindi ba dependent siya sa temperature? Okay? Yes, it's true. Yeah, it's dependent sa temperature. Pero wala namang binigay na temperature sa atin. Saka huwag ka nang papakahirap kasi konti lang yung variation sa 1. Like 0.98, 0.97 something. Okay? Huwag kayo maghanap, again, what I have told you, huwag kayo maghanap ng wala. Alright? So 1 gram per 1 ml. Okay? Then, what's next? Convert to kilograms. So 1,000 grams here sa ilalim, then 1 kilogram sa taas. So now you have these IKBM. So mole solute per kilogram of water or solvent. Okay? Then plus, don't forget the TB note. Sir, hindi naman po given. Again, it's water. So you assume na normal boiling point ito. So 100 degrees Celsius. Okay? So i-add natin. Your TB will be equal to, answer is 100.44 degrees Celsius. So yeah, I hope you have the same answer kagaya sa akin. Okay? So 100.44. Next, again, do this on your own. Okay, assignment nyo. Sana nagsasagot pa kayo ng assignment, no? So kahit busy kayo sa life, ganyan, gawin yung stress reliever ang pagsasagot ng problems. Okay? So what's the percent dissociation of HF? Okay? So obviously, HF is a weak acid, kaya tinatanong kayo ng percent dissociation. So you can obtain this from the data of the colligative, which is specifically the freezing point depression. Okay? So the answer is 8%, 8.0 something, I think. The one thing that you need to assume here is that your solvent is water. Okay? So most of the time naman kasi 'di ba, our solvent is water. So since kahit walang nakabigay dito, that will be your first assumption. Okay? That the solvent is water. So the answer is 8%. So I hope na gets nyo kung paano siya i-compute. Now let's go to activity. So ano bang activity? It refers to the effective concentration of non-ideal electrolytes which heightens the heighten kasi electrolytes yung ano mo dito, yung subject. Okay, heighten the interaction between the ions of the solute and the solvent. I had discussed this earlier. When you say heightened, merong malakas na interaction between the solute and the solvent particles. Okay? And the concentration and the kagaya ng sa non-ideal gases, okay, kapag naging significant na yung interaction nila, okay, hindi mo na siya pwedeng tawaging pressure, but you call it more appropriately as fugacity or effective pressure. Parang ganun din yung solutions natin. Okay? Maliban sa pagiging gas, the solute and the solvent particles, they have interaction between their particles, no? Pag mataas ang interaction, ibig sabihin, it will affect the concentration and it becomes the effective. Okay? So activity is the effective or real. You can think of that as real or non-ideal concentration. So paano ba sinosolve ang activity? So activity is equal to gamma times unit of concentration, times measurement of concentration. Okay? So pwede siyang molality. Most common lang dito sa activity is molality, pero pwede ring iba. Basta concentration. Okay? Gamma times concentration. By the way, your gamma is called the activity coefficient. Activity coefficient. Ayan. Then your M is molality for common, na pero this stands generally for concentration. Okay? Unit of ideal. Ito na yung sa ideal concentration. Okay? Now, the activity of the solute in a non-ideal solution is given by this equation. So, A can be estimated, activity can be estimated by the activity of the formed solution, formed ions sa solution raised to nu. So, nu is the stoichiometric coefficient. Sorry, mamaya mapakita pala yung nu. Nu is the sum of nu plus and nu minus. Okay? And it is equal to activity coefficient raised to nu times the molality. So, parang ginanto lang natin siya. Okay? Now, if you're not into some nitty-gritty of the equation, okay, so the mean ionic molality is this one, and the nu here, the overall nu, is equal to the nu of the cation plus the nu of the anion. Again, when you say nu, it means the stoichiometric, nu means the stoichiometric coefficient sa balance reaction. Okay? So therefore, okay, this is the final form. Okay? Again, hindi na ako masyadong nag-go sa nitty-gritty nitong mga derivation na to. Ito na lang, it's fine. So activity equals gamma raised to nu plus raised to nu plus, nu minus times nu minus raised to nu minus, m raised to nu. Okay? So ito lang, kahit itong blue na lang yung i-memorize niya. Okay? Actually, parang wala pang natanong na computation recently in your board exam. Wala pa. Okay? In the recent board exams. So, I think concept. Okay? Concept yung tinatanong dito. Pero, let's go into the computation. Simple lang naman siya if you know the formula. Okay? I mean, hindi pala simple. Yeah, it's simple but tedious. Medyo tedious. So, let me give you an example. Give the activity expressions only. Give the activity expressions for the following ions. For the following electrolytes. Okay, so NaCl and calcium phosphate. So again, let me do the first one. Akin muna yung madali, tapos inyo yung medyo challenging. Okay, so here are the answers. Again, mamaya ko i-reveal yung answer nung pangalawa. So for NaCl, ganito siya. Again, you just have to know the formula. So the formula is, again, activity is equal to activity coefficient raised to nu, okay? Then nu plus raised to nu plus, nu minus raised to nu minus, m raised to nu, okay? All right. So NaCl obviously will be dissociated as, again, Na plus and Cl minus. Now let's substitute. So A will be equal to gamma. The nu, again, the nu here is the sum of the nu plus and nu minus. So it is 2. Okay? Tapos ano ba yung nu plus natin? Coefficient ito is 1. So 1 raised to 1. Ito din 1. So times 1 raised to 1. Then m raised to 2. So if you rearrange or if you simplify, this will be gamma squared m squared. Okay? So kayo naman yung gumawa sa calcium phosphate. So for calcium phosphate, here is the answer. Okay? 108 yung coefficient. Then 5 yung exponent. Okay, now, I have to point out na, again, hindi nga ito masyado natatanong sa board exam, but if you will still remember, saan ginagamit ang mga activity? This is used sa mga KEQ expressions na real, na sa halip na ang isubstitute nyo is the molar concentration activity yung sinasubstitute natin. Okay? So yun, parang kinonect ko lang, parang tinahilang natin yung relationship ng activity, saan ba siya ginagamit, why do we have to compute for it. Okay, so I hope nakuha niyo yung number 2. Alright, so next, how will we get yung M kasi, of course, that should be given, yung concentration or yung molality. But here, in order to get the activity, you need gamma. So how will you get gamma? Okay, so gamma can be obtained from the Debye-Hackel theory. So the Debye-Hackel theory accounts for the deviation of electrolytes to normal behavior. Again, the reason is due to the heightened electrostatic interaction, okay, between the solute ions and the solvent, okay, particles. All right, so for an ideal solution, wala kayong problema. Your gamma is just equal to 1. Thus, your effective concentration is just equal to the actual or the ideal concentration. So, walang problema. So A is equal to gamma times M. Okay, in order to solve for gamma, several equations can be used depending on the concentration of the solution. Okay, so this is the most famous, the Debye-Hackel limiting law, or the DHLL. It is in paper, you should use it if the I is ionic strength. Okay, pwede itong lumabas din sa inyong analytical. So I, ionic strength. Sa Phi-Chem I, sa analytical, the symbol is mu. Okay, so mu or I is equal to, okay, 1/2 summation ng CI ZI squared. Nasa review guides niyo yung mga behind the scenes na formula. Okay? So that's how you compute for the I. And again, for technicality purposes, 0.01 ang value. You will use it if the ionic strength is less than 0.01. But heads up, no? Heads up, kahit yung iba, kahit lampas sa 0.01, as long as it is close, okay? Mas ginagamit na nila, they also use the Debye-Hackel limiting law. Alright? So, ano ba ang Debye-Hackel limiting law? Log of gamma is equal to A. So, A is a constant that is dependent on the solvent. So, A for water. Okay? So, again, dapat for water, sana kabisado natin. The A for water is equal to 0.509. Nasa review guide nyo din to. 0.509. Z. Okay, wag malilito sa nu at Z. So, Z is the charge. Okay? Charge to. Yung Z plus at Z minus. So, since this is multiplication, tas meron kang positive at negative, you will expect na yung nasa right side ng equation nyo will be negative. Negative ang value nito. So, kapag inantilog nyo yung something that is negative, you will get a gamma that is less than 1. Your gamma, of course, should be less than 1 for non-ideal solutions. Okay? Dapat less than 1 yung gamma. So, pag nag-compute kayo, tapos lumabas sa inyo is gamma na greater than 1, mali kayo. Okay? There's something wrong with your solution. Okay? So, very easy formula. Okay? So, log gamma is equal to AZ plus times Z, A times Z plus times Z minus times the square root of I or the ionic strength. Now, ito yung sinasabi ko. Kung meron naman na so again, kung meron naman na range na gamma na 0.01 to 0.1, okay? Technically, we use the extended Debye-Hackel law. So, extended DHLL. Okay? But then again, mas i-prioritize nyo muna. Okay, i-prioritize nyo muna yung i-prioritize nyo muna yung DHLL. So, gamitin nyo muna yung DHLL na kasi yun yung grandmother of these succeeding equations. So for the extended Debye-Hackel law, there are additional constants that were used. Okay? So may mga additional constants. And syempre, of course, it's not expected of you to know these constants here. Kahit na sabihin natin na for water, parang ang dami na masyado for just one equation. And kung malapit naman yung I nyo sa 0.01, again, what I have said earlier, you can use the DHLL, yung mas simpleng formula. Okay? Pag na lang walang lumabas sa choices, saka na lang kayo mag-panic na extended Debye hackle na pala yung gagamitin. Okay? And lastly, if you have greater than 1, ayan, so medyo malayo na. Paglampas na ng paglampas na ng 0.1, okay? Pwede na kayong gumamit ng Davis equation. So yeah, Davis equation is log of gamma is equal to A z plus times z minus. As you can see, pareho lang yung first part dito, ito, parehas lang, this one, parehas lang ng Debye hackle limiting law. Sa DHLL, this whole thing was just square root of I. Pero nagdagdag ka ng several factors here, several terms added para maging Davis equation. Okay? So, sir, do we need to memorize this para safe? Yes. But kung ganito nakahaba yung equation, like sa this equation here, Davis, piling ko ibibigay. Kasi dati, nagkaroon daw ng board exam na pati Van der Waals EOS, binigay pa. Eh, alam ko naman, kabisado nyo na yun. Yung Van der Waals EOS. So, somehow, they are merciful on that part na kapag merong complicated formulas, pinibigay. Okay? Pero again, we cannot hope for mercy all the time. Hindi tayo dapat mag-rely lang sa kung ano yung mercy ng someone na nakakataas sa atin. Okay? We have to fight on our own. Okay? We have to memorize our equations kung kaya pa. Okay? Nasa inyo naman yan kung kaya nyo pa. Alright? Pero again, the bare minimum is that you must know the other equations na madadali talaga. Pero pag mga ganito complicated, mahabang equations, pwedeng di nyo i-memorize kasi may chance na ibigay ito sa boards. Okay? Alright. So, let's now proceed to our example. Okay? So, solve for the activity of 0.005 molar aqueous solution of the following ions. So, assume DHLL is applicable. Okay, so first, KCl. So, syempre, ako ulit yung gagawa ng madali. Okay, so KCl and calcium nitrate. Okay, so doon muna tayo sa KCl. So, KCl, so first, of course, madali muna. K plus plus Cl minus. Okay? So, activity na yung kinukuha natin. So, again, in order to get the activity, you need gamma. Okay? Activity coefficient. And in order to get gamma, you need I from the Debye hackle limiting law. So, I or mu, ionic strength, will be obtained from the summation of, again, formula is I is equal to 1/2 times the summation of concentration times the charge squared. Okay? So now, okay, if 0.005 ang initial concentration ng KCl, upon dissociation, this will be 0.005 as well, yung concentration ng K+, and the Cl minus will be 0.005 as well. Okay? Kasi, simply because 1:1. Okay? 1:1 yung ratios nila. So, if this 0.005, upon dissolution, you will have 0.005 then na concentration for K plus and Cl minus. Okay? So, let's now get the I. So, I is equal to 1/2 summation ng CiZi squared. So, dumuna tayo sa K plus. So, for the cation, the concentration is 0.005. Okay? Then, the charge is positive 1 squared. Okay? Plus 0.005 for the Cl minus times negative 1 for the charge squared. Okay? Hindi naman magmamatter yung pagka-negative kasi is square naman. Okay? So the answer here will be 0.005 then. We can now proceed in the DHLL. So the Debye hackle limiting law, log of gamma is equal to A Z plus Z minus square root of I. That's the formula. So log of gamma is equal to, ang A natin is 0.509 if you remember. Okay, for water. So Z plus, the charge is positive 1. The charge for of the anion is negative 1 times the square root of 0.005. Don't mind the units, hayaan nyo na. Yung units dyan, baka lang malito kayo. Okay? So, your gamma, pwede nyo nang i-shift solve to. Okay? You can just apply shift solve function here para makuha nyo yung gamma. And our gamma is equal to 0.9205. Ayan. 0.9205. Yeah, that's our gamma. Okay? Now next, let's go to the activity. The formula for activity, if you remember, is gamma raised to nu plus, raised to nu plus, times nu minus, raised to nu minus, m raised to nu, m raised to nu. Okay? So substitute, gamma is 0.9205 raised to nu. Ilan ang nu natin? Okay? Again, nu is the total ion. So, dalawa. 1 saka 1. So, our nu is 2. Our nu plus, okay, nu ng cation or the stoichiometric coefficient ng cation. So, that is 1. So, 1 raised to 1 times, ito namang nu minus raised to nu minus. That is also 1 raised to 1. So, para lang tayo naglolokohan ng 1 at 1. Okay? Then, m, the concentration is 0.005. So, 0.005 raised to nu. Our nu is the sum of the coefficients of the ion. So, that is 2. So, yun na. Makukuha nyo na. Your activity will be equal to 2.12 times 10 to the negative 5. Okay? So, here is the answer for 1 for KCL. Okay? So, I hope na-recall nyo na. Alright? And the answer for 2, pakigawa on your own yung 2. So, same ng procedure ha, para hindi kayo malito. Okay? Now, the answer for 2 is 2.11 times 10 to the negative 7. Okay? Now, if DHLL is applicable, nung kinompute ko na applicable ang extended DHLL dito, ang nakuha kong value is 2.17, if I'm mistaken, 2.17, which is fairly close dun sa activity kung DHLL yung i-assume nyo. Okay? Again, sa board exam, kung hindi nakastate na extended Debye-Hackel limiting law yung gagamitin, okay, of course, you should assume that DHLL will just be used. Okay? So, yun muna. Pag walang lumabas, again, saka kayo magpanic na gagamit kayo ng extended version. Okay? Pero normally, malapit lang naman sila. Malapit lang yung value. Okay? Ginawa lang yung extended DHLL para mas exact yung estimation. Okay? So, sana mapalabas nyo yung 2. And guys, yun na. That's it for the non-ideal solutions.